Hi, don't forget to check out my course for the Quant section of the CAT exam where I've explained all concepts, tips and tricks, shortcuts, and past year questions in great detail. Fraction of a is to b. Alright guys, please solve this next question from CAT 2017. Okay, so the question says the number of solutions x, y, and z to the equation x minus y minus z equals 25, where x, y, and z are positive integers, such that x less than equal to 40, y less than equal to 12, and z less than equal to 12 is. Very interesting question. Let's see how we solve it. So the condition is x minus common y plus z is equal to 25. All right, guys. Now the first case we will consider is suppose when x is 26. Now if x is 26, we can write this expression, we can write the equation as 26 minus y plus z is 25. But then we have a problem here. This gives us y plus z is equal to 1. If x, y, and z are all positive integers, none of them can be 0. Basically, all of x, y, and z are definitely greater than 0. But if y plus z is 1, either of them have to be 0. That's impossible. That means x cannot take the value 26. The minimum value x can take is 27. So if I take x as 27, this equation now becomes 27 minus y plus z is equal to 25, giving you y plus z is equal to 2. And that gives me only one solution when y and z both are equal to 1. Right? So taking the value x as 27, I get only one solution. X is 27, y is 1, and z in 1. This is the only one solution which I have, right? Now, next case we can consider when x is equal to 28. When we do that, guys, we are going to get 28 minus y plus z is 25, or we will get y plus z is equal to 3. Now, this will give me two solutions. 1, 2 for y and z respectively, and 2, 1 for y and z respectively. Right? So I have two solutions. What if x is 29? That will give me 29 minus of y plus z is 25. I will get y plus z is equal to 4. Now this has three solutions. Okay guys, and this we can observe will continue up till x is equal to 39. If x is 39, we will get y plus z is equal to 39 minus 25, that's 14. This will give me exactly 15 solutions. Okay, from y is equal to 1, z is equal to 13, up to y is equal to 13, z is equal to 1. 13 solutions you have here. But guys, we have a small problem here. Y and z each has to be less than 12. So I have to subtract two cases from here, right? The two cases are when y is 1 and z is 13, and y is 13, z is 1. None of them can be 13, right? So basically we remove one case when both of them are 13. So here I don't have 13, I have only 11 possible solutions, right? Now, the last possibility is that if I take x as 40, I will get y plus z is 15. Now, in this case, y can't take the value 1 because z will become 14, exceeding 12. Y can't be 2 also because z becomes 13. The minimum value y can take is 3. Accordingly, z becomes 12. Next value is 4 and 11. This goes on up till 12 and 3. So like this, there are 10 possible solutions. Okay, y will take values 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 10 solutions or b minus a plus 1. 10 possible values of x, y, and z. So overall, I have 1 plus 2 plus 3 plus 4. Okay, up to 13 minus 2 values, or 1 plus 2 plus 3 plus 4 up to 12 plus 11 plus 10. So total number of solutions is 1 plus 2 plus 3 up to 12 plus 11 plus 10 is 21. So 1 plus 2 plus 3 up to 12 is sum of the first 12 natural numbers. N into n plus 1 divided by 2 plus 21 So 13, 6 are 78 and 21. In all, I have 99 possible solutions. Option B. Very amazing question. That's how we solve it. Okay, guys, please do give this one a try and then you can resume to look at the solution. Okay, guys, so we have a and b as integers and opposite signs such that a plus 3 the whole square is to b square is 9 is to 1. Now, from this equation, guys, if we take square roots on both sides, we will get either a plus 3 upon b is 3 upon 1 or a plus 3 upon b is minus 3 upon 1, right? Similarly, from the second condition, if you take square roots, we will get a minus 1 upon b minus 1 is 2 upon 1 or a minus 1 upon b minus 1 is minus 2 upon 1. Now, we'll have to check for combinations, guys. First, these two, then second combination is these two, then third combination is these two, and then these two. And we'll basically find out the possible values of a and b. So let's take the first case, guys, when we combine these two conditions, right? We basically get a plus 3 is 3b. And the second condition from here will be a minus 1 is 2b minus 2. So in this, we will get a is equal to 2b minus 1, which we can put in the first equation. So in place of a, we will put 2b minus 1, right? So we are going to get 2b minus 1 plus 3 is 3b. That gives me the value of b as 2. Okay, now in this, if I put b is equal to 2 in any of these two equations, either this or this, I will get the value of a. A will be equal to a plus 3 is 3 into b. 3 to the 6 minus 3 is 3. But here we get both a and b as positive, whereas the question says they are of opposite signs. So this solution is not true. That means we'll have to check for the other combinations. Okay, guys, the next combination we check for is this and this. So first equation basically gave us a plus 3 is 3b. And the second equation gave us, this one will give us a minus 1 is minus 2b plus 2. So a will be minus 2b plus 3. And again, this we put in the first equation. So in place of a, I will put minus 2b plus 3 is equal to 3b. But if you take minus 2b on the right hand side, you get 5b is equal to 6. Not possible because b won't be an integer. So we ignore the second solution also. The next possibility is combining these two equations. From the first one, I'm going to get a plus 3 is minus 3b. And from the second one, I will get a minus 1 is 2b minus 2, thereby giving you a is 2b minus 1. Again, I will put a is 2b minus 1 in this equation. So 2b minus 1 plus 3 is minus 3b, thereby giving you minus 5b is 2, and b won't be an integer. So this case also is ruled out. And thus, if we look at the last possible combination, we combine these two, we will get a plus 3 is minus 3b. And from here, a minus 1 is minus 2b plus 2. So basically, we will get a is minus 2b plus 3. And that's it. We substitute this in the given equation. So minus 2b plus 3 is minus 3b. So this will give us minus b is equal to 6 or b is equal to minus 6. Substituting b is equal to minus 6 in any of these two equations, we'll get the value of a. So putting it here, a is minus 2b. Minus 2 into minus 6 plus 3 is minus 2 into minus 6, 12 plus 3, 15. So a is 15 and b is minus 6, satisfying both the conditions. A and b both are integers and of opposite signs. Now we need a square is to b square. The answer we need is 15 square divided by 6 square. That's 225 divided by 36. Cancelling out the value 9. 25 by 4 is the final required answer. Option D. Slightly lengthy, but not a difficult one, of course. And that's how we solve it. The answer is option D. 25 is to 4. All right, guys, please try this next question based on functions and graph, and you can then resume to look at the solution. Okay, so basically, if you consider mod x plus mod y equal to 2, guys, we can construct this diagram in the four quadrants, okay, somewhat like this or in the following manner. So this is the y-axis and this is the x-axis. If you consider the first quadrant, guys, in the first quadrant, x and y, both the terms are positive. So mod x will be equal to x and mod y will be equal to y. The equation will be x plus y is equal to 2. X plus y is equal to 2 is a straight line having x and y intercepts both equal to 2. So it will be something like this, right, guys? Now, in the second quadrant, okay, we know that x is negative and y will be positive. So mod of x will be minus x and mod of y will be y only. So we will have minus x plus y is 2. Now this equation has x-intercept minus 2 and y-intercept plus 2. So if you draw the line, it will be something like this. Okay, in the third quadrant, both x and y will be negative, right? And in the fourth quadrant, we observe that we have x is positive and y is negative. So this is how your graph would look like. Okay, kind of the graph resembles a square. Okay, so the question is how to find out the area of this region. So one way is you find out the side of the square here. Okay, and you take the square of the side, you get the area. So this length is 2 and this length is 2. Okay, we can find out the value of this side, let's say x, or we can find the value of x square. Directly we get the area. Now by Pythagoras theorem, x square will be equal to 2 square plus 2 square, that's equal to 4 plus 4, that's equal to 8, right? So side square is equal to 8, and that's the answer to your question. The area of the region is 8. Okay, guys, another general approach you can use in these questions now is if you have mod x plus mod y is equal to, let's say, a, guys, we can observe that in all the four quadrants, we will have triangles, right? Actually, isosceles triangles having perpendicular sides, a units each. So area of one such triangle will be half into base into height. Like that, we have four such triangles. So area will be 4 into this value. Now we have a quick shortcut for all these questions. So if you have mod x plus mod y is equal to 2, the area which you require will be 2 into 2 square. That's 2 4s are 8. Option C. And that's exactly how I personally solved the question in the exam, 2a square. I could like probably get the answer in 3 to 4 seconds. That's all. The answer is option C.
Hi, don't forget to check out my course for the quant section of the CAT exam where I've explained all concepts, tips and tricks, shortcuts and past year questions in great detail.
Fraction of a is to b.
Suppose log of x to the base x to the base 3 is equal to log of y to the base 12 is equal to a, where x and y are positive numbers. If g is the geometric mean of x and y, then log of g to the base 6 is equal to. All right. Again, whatever is given to us separately, पहले break करते हैं उसको. Log of x to base 3 अगर a है, तो 3 raised to a हो जाएगा x. Okay. Same way, log of y to the base 12 अगर a है, y क्या हो जाएगा 12 raised to a. Okay, now g is the geometric mean of x and y. Okay, guys, geometric mean दो numbers का क्या होता है? For two numbers a and b, geometric mean is square root of a into b, right? So basically g square will be equal to x into y, or g is root xy. Okay, so in place of x we substitute 3 raised to a, and in place of y we substitute 12 raised to a, right? So g square becomes 3 raised to a into 12 raised to a. Okay, now powers are common, 3 raised to a, 12 raised to a. What we do is, okay, we take the power outside, power common, so it will become 36 raised to the power a, right? So basically ऐसा हो जाएगा. Okay, 3 raised to a है, 12 raised to a, so ये क्या हो जाएगा 3 into 12, 12, 3 into 12 the whole raised to a, right? Okay, so 3 12 is 36, so g square is 36 to the power a in this case, right? So if g square is 36 to the power a in this case, हम लोग क्या बोल सकते हैं, g square is equal to 6 square the whole raised to a. Okay, or you can also say this is the g square is 6 raised to a the whole square, ये भी बोल सकते हैं हम लोग, right? Now take square roots on both sides. Okay, you will simply get g is equal to 6 raised to a. Okay, अब क्वेश्चन क्या बोलता है, फाइंड द वैल्यू ऑफ log of g to the base 6. Okay, g का वैल्यू क्या है, 6 to the power a, take a outside, 6 to the base 6, the answer is a, and this is again the D option.
Alright guys, so you can try this question and you can resume for the solution. Now you have to be very careful what the question is asked actually. So the question is asking f of g of x plus g of f of x, this whole thing find f of. Okay, this is our question. At x equal to 1. So technically we are required to find f of g of 1 plus g of f of 1. This is our question. Alright, so let's solve. We have been given f of x is equal to x square, guys. In this, if I substitute x is equal to 1, I will get f of 1 is equal to 1 square, which is equal to 1. So this entire term I can simply replace by a 1. Similarly, g of x has been given as 2 raised to x. So in this, if I put x is equal to 1, I will get g of 1 will be equal to 2 raised to 1, and that is 2. So g of 1, in place of g of 1, I can simply substitute a 2. So now this entire expression here, this boils down to f of, in place of g of 1, I'll put a 2 plus g of, in place of f of 1, I will simply put a 1. Okay, this is our next step. So now the entire expression is f of 2 plus g of 1. Now f of x is x square. So f of 2 will be realized when you put x equals to 2. When you put x equals to 2, f of 2 is equal to 2 square, which is 4. Similarly, when I put x equal to 1 in g of x, I will again get g of 1 as 2 as already found. Now I substitute both the values. This entire expression would become f of 2 is basically 4 plus g of 1 is basically 2. So finally I would be needed to find the value of f of 4 plus 2, and that is f of 6. So my final step here is to plug in the value of x as 6 in this particular equation. When I do that, I will get my answer, f of 6 is equal to 6 square, and that's nothing but 36. And as you can see, this clearly matches with the C option. And that's the answer to our question, option C. Simple question, just 2-3 steps. Using composite functions, you can solve this.
Hi guys, this is your next question from CAT 2018, the first lot. Please pause the video and try it once, and you can resume for the solution. Alright guys, so we have an equation. The left hand side is suppose A and the right hand side is suppose B. Now guys, if A and B are equal, their powers will be same, right? And log means power. That means if I take log on both sides to some base x, log of A to the base x will be equal to log of B to the base x, right? Similarly, if 2 raised to x is equal to 3 raised to log of 2 to the base 5, let us take log on both sides. The first term on the left hand side will become log of 2 raised to x, and on the right hand side you will have log of 3 raised to log 2 to the base 5. Now we can select any base for the log here. I am selecting the base 5. You will get to know very soon why I am doing this. When I equate these two now, notice that this is log of 2 raised to x to the base 5. By the laws of logarithm, x will come outside in the numerator. So this part will simply become x into log 2 to the base 5 is equal to, on the right hand side, we have log of 3 raised to something to the base 5. So this power will come outside in the numerator. You will have log of 2 to the base 5 into what remains is log of 3 to the base 5. And now if you see it, when you see it, log of 2 to the base 5 will get cancelled out from both sides. I directly get the answer, x will be equal to log 3 to the base 5. Now we can observe that none of the option directly matches with this. But if you want, now you can eliminate the options. Like the first option says log of 9 to the base 5. 9 can be written as 3 square. And again, the 2 will come outside in the numerator.
So this part is actually 2 log 3 to the base 5, which is not what we want. Let's look at the B option, guys. B option is 1 plus log 3 by 5 to the base 5. If I simplify the B option, I will get 1 plus log of 3 to the base 5 minus log 5 to the base 5. This is our laws of logarithm, right? Log of x upon y is log x minus log y. Now, log 5 to the base 5 will be 1, minus 1 and 1 will get cancelled out. Finally, I get log of 3 to the base 5 only. So yes, this is my answer, option B. Okay, okay. Now, this is one way of solving the question, guys. There is an amazing shortcut to this question which I've discussed in my course. You can check out the link in the description for the same.
Find the value of log of root 5 to the base 0.008 plus log of 81 to the base root 3 minus 7. The options are given to you. You can again just pause the video and check this question and just try out solving it. And then you can resume to look at the solution. All right, guys. Now the challenge here is to identify the relation between the numbers and their bases. Okay, so if you observe, देखो ये तो बहुत simple है. 81 दिया हुआ है. 81 is nothing but 3 raised to the fourth power, and root 3 is nothing but 3 raised to half. तो यहाँ से हम 4 और half बाहर निकाल सकते हैं from the third property of logarithms, right? Okay, something similar we'll try to apply over here because but the problem is that it's not very much evident. यहाँ पे 3 और 18 81 दिख गया directly आपको, right? Okay, so what you need to observe here is 0.008 दिया हुआ, right guys? 0.008 is nothing but 1 upon 125. Okay, so that's exactly what we'll do right now here. Okay, right, we'll write the 1 by 125 as 1 by 5 cube. Okay, or basically 5 raised to minus 3, and this root 5 will write as 5 raised to half. Okay, that's the whole plan here. So let's implement it slowly. Okay, in the first step, we wrote the base 0.008 pehla wala as 1 by 125 and root 5 as 5 raised to half. Okay, दूसरे वाले में we write the base as 3 raised to half and the power as 3 raised to 4. Okay, now we take 5 cube as 125 in the first part, and दूसरे वाले में से we take 4 and 1 by 2 outside. Okay, in the denominator, and log 3 to the base 3 will cancel out to give you 1. Okay, so 4 upon half, ये part कितना हो जाएगा guys? 8 upon 1 हो जाएगा अगले वाले part में, right? Okay, and this 1 upon 5 cube we now wrote as 5 raised to minus 3. Okay, now take half and minus 3 both outside, so you'll be left with 1 by minus 6 plus 8 minus 7 ये हो जाएगा 1, and ये तो 1 है ही है, log of 5 to the base 5, right? So the answer is 1 minus 1 by 6 or 5 by 6, और ये CAT 2017 question, right? Can you believe it? So simple. Okay, now many people argue कि बहुत calculated है, simple कैसे होगा? Simple because I personally solved this question within 45 seconds in CAT because I remembered the value. I rather knew the value 0.008. Okay, even if you do not know, it's very simple to observe, guys. देखो अगर यहाँ पे 8 दिया हुआ है, 8 is 2 cube. Okay, आपको किसी 1 के या 10 के पावर से रिलेट करना है इसको, right? So 8 is 2 cube, right? 2 cube into 5 cube we know should be 10 cube, right? यहीं से आपको अपना समझ में आ जाएगा, right? कि this is nothing but 125 being, or this is 1000. Okay, 10 cube is 1000 divided by 8. Okay, 1000 divided by 8 is nothing but 125 in this case, right? Okay, आपको क्या चाहिए? 0.008 चाहिए, right? Okay, so इसको invert कर दो. Okay, 8 divided by 1000 is equal to 1 by 125. Okay, so even if you do not know the powers of 5, you can still reach at this particular value. Might take some time, okay, if you're not very much through with numbers, but aa jayega, not a problem. Okay, given that x plus 1 is equal to x square and x is greater than 0, then 2x raised to 4 is, okay, CAT 17 question hai guys. Okay, and let's see how very easily we can apply the quadratic formula once and just square it twice to get the answer. We have been given x square is equal to x plus 1. We write this as x square minus x minus 1 as 0. Applying the quadratic formula, you find the value of x minus 1, minus or minus 1 basically, plus minus root of minus 1 square minus 4a into minus 1 upon 2. So you get x as 1 plus or minus root. Minus 1 square will be 1. Minus of 4 into minus 1 is basically 4. 1 plus 4 is basically 5 divided by 2. Now the question says that x is positive, right guys? But if you take x is equal to 1 minus root 5 upon 2, ये part तो negative हो जाएगा. Root 5 approximately 2.3 के आसपास है. So this part is negative, right? So this is ruled out. Okay, we cannot have a negative value of x possible. So the only possible value of x is 1 plus root 5 divided by 2. Okay, that gives you x is 1 plus root 5 upon 2. Now when you square them guys, you will have x square is equal to 1 plus root 5 the whole square divided by 4. Okay, now 1 plus root 5 if you square guys, it will be a square plus b square plus 2ab, right, divided by 4. Okay, so that gives you x square is equal to 6 plus 2 root 5 divided by 4. You can cancel out the 2 everywhere, right? So this will give you x square is equal to 3 plus root 5 divided by 2. Just bear with me for 1 second. We need to square it again and we have the answer in one step. Okay, square it again. Left hand side becomes x is to 4. Okay, और यहाँ पे क्या हो जाएगा 3 plus root 5 the whole square divide by 4. That gives you 9 plus root 5 का square is 5. 2 3 is 6 into root 5 is 6 root 5 divided by 4. Okay, 9 plus 5 will be 14 plus 6 root 5 upon 4. Again, you can cancel out a 2 everywhere, guys. So you will have x raised to 4 is equal to 7 plus 3 root 5 divided by 2. But हमें x raised to 4 नहीं, हमें 2x का वैल्यू चाहिए, right? 2x raised to 4 का वैल्यू चाहिए, right? हमें x raised to 4 का नहीं, हमें 2x raised to 4 का वैल्यू चाहिए, right? So multiply by 2 on both sides or take the 2 on the left hand side. You will get 2x raised to 4 will be nothing but 7 plus 3 root 5. This is option D.
All right, guys. So let's look at another very quick way and a very effective way to solve the question. If x plus 1 is equal to x square and x is greater than 0. So basically, we want to satisfy this condition by taking some value of x. So in this case, we can plug in the value of x here on both sides and try to satisfy the equation. Now, if x is positive, if you put x is equal to 1, guys, the left-hand side becomes equal to 2, the right-hand side becomes equal to 1. They're not equal, right? So we basically need to increase the right-hand side slightly. Okay, so what if I take 1.1? 1.1 square is 1.21. On the left-hand side, I will have 1.1 plus 2, 2.1. That's still not equal, right? Now, by taking a few values, like for example, if you take 1.4 for that matter, 1.4 square is 1.96, 1.4 plus 2 is 2.4, still not equal. You can take 1.6. If you take x is 1.6, guys, 1.6 square is 2.56 and 1.6 plus 1 is 2.6. Approximately they're equal, right? So x ka value is basically 1.6 approximately. Okay, if x ka value is approximately 1.6, the value of 2 into x raised to 4 is 2 into 2.56 square because x square is 2.56, right? So this will be 2 into 2.56 the whole square. And this will be 6.55 approximately. Okay, and twice of that will simply be equal to 13.1. Okay, now we simply check which of these options is approximately equal to 13.1. So root 5 basically is 2.23. Okay, 2.23 approximately into 4 plus 6 is 14.92. The first option is 14.92. Next option is 5 into 2.23 plus 3 is again 14.15. No. Next is 2.23 into 3, 6.69 plus 5. This is 11.69. And the last one is 3 into 2.23 plus 7. This is 13.69. Yes. So roughly this is what we want. Option D is the correct answer. Okay, guys, let's solve the next question from CAT 2017. Please do give it a try. It's a very simple question. Please try it out, then we'll discuss. All right. So if A, B, C, and D are integers such that A plus B plus C plus D is 30, then the minimum possible value of A minus B the whole square plus A minus C the whole square plus A minus D the whole square is. Okay. So guys, we want to minimize this expression A minus B the whole square. a minus c the whole square, and a minus d the whole square. Now this expression will be minimum when a, b, c, and d will be as close as possible. Okay, if we try to make them equal, the sum is 30. So all of them can be 7.5 each. But since they're integers, okay, we can take some of them as 7 and some of them as 8. So the values of a, b, c, and d in some order could be 7, 7, 8, and 8. Okay, now we can take any of these values as, let's say, 7. Let's say a is 7. Okay, b is 8, c is 8, and D is 7. Okay, you take them in any of the order now, you will get the answer very, very quickly. 7. Okay, if we are taking A as 7, B as, let's say, 8, C as 8, and D as 7. Now, order does not matter, guys. Any of the any of the values you take for A, B, C, D now, ultimately the answer will be same. So A minus B the whole square will be 7 minus 8 the whole square, plus A minus C the whole square is again 7 minus 8 the whole square, and a minus d the whole square is 7 minus 7 the whole square. This is 1 square 1, 1 square 1, 0 square 0. 1 plus 1 plus 0 is 2. That means the minimum possible value of this entire expression is 2. You can cross-check by taking any other values possible for a, b, c, d. You will end up with the same answer, 2 in every case. So the answer here is 2.
Hi, don't forget to check out my course for the quant section of the CAT exam, where I've explained all concepts, tips and tricks, shortcuts, and past year questions in great detail.
Fraction of a is to b.
Alright guys, please try this question and you can resume for the solution. So let's solve the question. The minimum possible value of the sum of the squares of the roots of the equation x square plus a plus 3 into x minus a plus 5 is equal to 0 is. You have to find out the minimum possible value of sum of the squares of the roots of this equation. Let the roots of the equation be alpha and beta. You are required to find out the minimum possible value of alpha square plus beta square. Now guys, we already know that for a quadratic equation, we have studied this in algebra, the sum of the roots is minus the coefficient of x upon the coefficient of x square. So alpha plus beta is minus of a plus 3 divided by the coefficient of x square here is 1. So here sum of the roots is minus of a plus 3. Similarly, we also know that the product of the roots is the constant term divided by the coefficient of x square. So it is minus of a plus 5 divided by 1. That's minus of a plus 5 again. And now what we need is alpha square plus beta square. It can be also written as alpha plus beta the whole square minus 2 alpha beta, right? So when you open this out, you'll get alpha square plus 2 alpha beta plus beta square plus 2 alpha beta, and minus 2 alpha beta will get cancelled out. So ultimately you will get alpha square plus beta square, right? I'm simply writing this expression as alpha plus beta the whole square minus 2 alpha beta. And now we have to plug in the value. So in place of alpha plus beta, we can substitute minus of a plus 3. I will get minus of a plus 3 the whole square minus. In place of alpha into beta, I can substitute minus of a plus 5. So minus 2 into alpha beta will be minus of a plus 5. And when I simplify this, minus of a plus 3 the whole square is like a plus 3 the whole square. A square plus 2ab plus b square. I have to be slightly careful here. Minus 2 into minus of a plus 5 is plus twice of a plus 5. This I can further simplify as a square plus 6a plus 9 plus 2a plus 2 5s are 10. Which boils down to a quadratic equation. A square plus 6a plus 2a will give me 8a, and 9 plus 10 will give me 19. I have to find the minimum value of this quadratic equation. Okay, so the entire question eventually boils down to finding out the minimum value of this quadratic equation. So now on we have several ways we can use the process of differentiation. If you know derivatives, you can differentiate with respect to a. You will get 2a plus 8 should be 0. A is minus 4. And second derivative is basically 2, which is positive. That means you have a minima or a minimum value, and that is obtained when you substitute a as minus 4 in the given equation. So minus 4 square plus 8 into minus 4 plus 19. 4 minus 4 square is 16. 8 into 4 minus is minus 32 plus 19. 16 and 19 is 35 minus 32 is 3. This is one way of solving. Here we can also use the concept of completing the squares. So we can write this quadratic as a square plus 8a plus 19 can be split as 16 plus 3. And now this expression is a plus 4 the whole square plus the extra 3. Now this being a perfect square will have a minimum value of 0, right? And that's how the minimum value of your expression becomes 0 plus 3, and that is equal to 3. This is another way out. The other way is we have also studied how to find out the maximum minimum of a quadratic. For any quadratic equation, the minimum or the maximum value occurs when x is minus b by 2a. So this means the minimum value of this quadratic equation will be at that value of x, which is equal to minus the coefficient of a upon twice the coefficient of a square in this case. So it is minus of 8 upon 2 into coefficient of a square here is 1. It is minus 4. And again, substituting x equal to minus 4, or in this particular context, the variable is a. Substituting a as minus 4, we get the minimum value of the quadratic. And this we have already done here, right? Same way we get the answer as 3. Different ways we'll get the same answer in all the cases. The answer would be option C. Hi guys, let's look at the next question from CAT 2017, the second slot. If log 2 raised to a into 3 raised to b into 5 raised to c is the arithmetic mean of log 2 square into 3 cube into 5, log 2 raised to 6 into 3 into 5 raised to 7, and log 2 into 3 square into 5 raised to 4, then a equals. So there are multiple ways to answer this question, guys. The first method is this here is the arithmetic mean of the three terms 1, 2 and 3. Arithmetic mean meaning the average. So one way is we can write the average of these three terms. We can find the average of these three terms and equate it with log of 2 raised to a, 3 raised to b and 5 raised to c. So let's look at that. The average of these three terms shall be log of 2 square, 3 cube and 5 plus log of 2 raised to 6 into 3 into 5 raised to 7 plus the last term is log of 2, 3 square, 5 raised to 4 and the average means divided by 3. Now guys, log a plus log b plus log c is actually log of a into b into c, right? So log of 2 square into 3 cube into 5 into 2 raised to 6 into 3 into 5 raised to 7 into 2 into 3 square into 5 raised to 4, the whole thing divided by 3 is what we need. So powers of 2 are 2 square, 2 power 6 and 2, they are getting multiplied. So all these powers of 2 get added. So log of 2 raised to 2 plus 6 plus 1 will be 9 into 3. The powers of 3 are 3 cube, 3 raised to 1 and 3 square. That's 3 power 6 into powers of 5 are 5 raised to 1, 5 power 7 and 5 raised to 4. That's 5 power 12. This entire thing is divided by 3. So this entire expression is divided by 3. This means it is like log of 2 raised to 9 into 3 raised to 6 into 5 raised to 12, the whole raised to 1 by 3. And this is what brings 1 by 3 outside and we have 3 in the denominator, right? So finally, we are going to get log of 2 raised to 9 raised to 1 by 3 is 2 raised to 9 into 1 by 3. That's 2 cube. 3 raised to 6 raised to 1 by 3 is 6 into 1 by 3. That's 3 square. Into 5 raised to 12 raised to 1 by 3 is 5 raised to 12 into 1 by 3. That's 5 raised to 4. So this here is the arithmetic mean of these three terms given here. And now we compare this with log of 2 raised to a into 3 raised to b into 5 raised to c. Comparing, we get a as 3, b as 2 and c as 4. That easily answers our original question as a being equal to 3. So this was the first way of answering the question. Now we have another way, guys. Let's observe something very interesting. If I have three numbers, let's say 3 raised to 4, 3 raised to 6 and 3 raised to 8. Notice that these three numbers are forming a GP where the common ratio is 3 square. 3 raised to 4 into 3 square is 3 power 6. 3 power 6 into 3 square is 3 power 8. So these numbers are in GP or geometric progression. We notice that when numbers are in GP, their powers, here the powers 4, 6 and 8 are in AP, arithmetic progression, isn't it, guys? Okay, and now applying the same concept, our question becomes really very easy. So we observe that logs of the three numbers are in AP. Logs simply mean the powers, right? And when the powers are in AP, just now we have seen that the numbers originally will be in GP. So the term 2 raised to a, 3 raised to b and 5 raised to c given here, it is the geometric mean of the other three terms, 2 square, 3 cube, 5, 2 raised to 6, 3 and 5 raised to 7, 2, 3 square, 5 raised to 4. So let's multiply all of them. 2 square into 2 raised to 6 and 2 is 2 raised to 9 into 3 raised to 3 into 3 square, 3 raised to 6 into 5 raised to 7 and 5 raised to 4 is 5 raised to 12. Okay, the geometric mean will be the cube root of all these numbers. So 2 raised to 9, the whole raised to 1 by 3 is 2 raised to 9 raised to 1 by 3 is basically 2 raised to 9 into 1 by 3, that's 2 cube. Similarly, 3 raised to 6, the whole raised to 1 by 3 is 3 raised to 6 raised to 1 by 3 or 3 raised to 6 into 1/3, that's basically 3 raised to 6 by 3 and that's 3 square. Similarly, 5 raised to 12, the whole raised to 1 by 3 will be 5 raised to 12 by 3 or 5 raised to 4. This now we'll compare with 2 raised to a, 3 raised to b and 5 raised to c. A is 3, b is 2 and c is 4. Super easy solution to our question. What they want is a is 3. Alright guys, so let's go on to the next question from CAT 2017, the second slot. You can pause the video and try solving it and then resume for the solution. So it's a very common question type that we have already discussed in our course also. You can check out the card flashing towards the right hand side corner of the screen right now, or you can check out the link in the description for the same question. Let's see how many different pairs a comma b of positive integers are there such that a is less than equal to b and 1 upon a plus 1 upon b is 1 upon 9. So we start by taking the LCM of a, b and 9 throughout, that is 9ab, and this equation will multiply throughout by 9ab, right? So 1 upon a into 9ab will be 9b plus 1 upon b, this term into 9ab will make it 9a, is equal to 1 upon 9, this term into 9ab is simply ab. Now take the other two terms, take both the terms on the left hand side to the right, you will simply get ab minus 9a minus 9b is equal to 0. And the next step is minus 9 into minus 9 would be plus 81. So we just add 81 to both sides of the equation. So between the first two terms, we can simply take an a common. So we get b minus 9. And between the other two terms, I can take a minus 9 common. It will be b minus 9 is equal to 81 plus 0, which is 81. So now take b minus 9 common, b minus 9 common. What remains is simply a minus 9. A minus 9 into b minus 9 is 81. So finally, it all boils down to finding the number of positive integral solutions for a minus 9 into b minus 9 is equal to 81. The condition is a should be less than or equal to b. So now the left hand side is product of two numbers and right hand side is 81. So let's factorize 81. One possibility is 1 and 81. So you get a as 10 and b as 90. A as 10 and b as 90. This is one possible solution. What if I write 81 as 3 into 27? So a minus 9 will be 3 or a will be 12. B minus 9 is 27, so B is 36. The next possible solution is, let's take both 9 and 9 each. So A minus 9 would be 9, giving you A as 18, and B minus 9 is also 9, giving you B as again 18. Any value you take for A and B further, let's say if I take 27 and 3, then A will be 36 and B will be 12. Well, that's not acceptable because in this question A is less than or equal to B. So I have only 1, 2 and 3. These three solutions. That's the answer to my question. There are exactly 3 positive integral solutions for A and B in this case.
All right, let's go on to the next question from CAT 2017, the second slot. You can pause the video and give it a try and resume for the solution. All right, let f of x be equal to 2x minus 5 and g of x be equal to 7 minus 2x. Then mod of fx plus gx will be mod of fx plus mod of gx if and only if. Let's observe the left hand side first. The left hand side is mod of f of x plus g of x. F of x is 2x minus 5 and plus g of x is 7 minus 2x. So left hand side is basically mod of 2x minus 5 plus 7 minus 2x. From this, 2x will get cancelled out and we simply have mod of minus 5 plus 7, and that is mod of 2. And mod of 2 is nothing but 2 only, right? So the left hand side of this question is basically fixed. The left hand side of this equation is fixed. The right hand side is mod of fx plus mod of gx. Okay, mod of fx will be mod of 2x minus 5 plus mod of gx will be 7 minus 2x. And sum of these two is equal to 2 only, as the left hand side is 2. So 2 is equal to mod of 2x minus 5 plus mod of 7 minus 2x. The next step is we divide throughout by 2. So dividing by 2, I will get 1 is equal to mod of 2x upon 2 will be x minus 5 upon 2 will be 5 upon 2 plus mod of 7 by 2 minus 2x upon 2 will be x only. Now guys, after this, I have two ways of approaching the problem. The first method is the conventional method where this part of the expression would become 0. This part becomes 0 when x would be equal to 5 by 2, and this part would become 0 when 7 by 2 minus x would be 0, or x would be equal to 7 by 2. Now drawing these two on the real number line, we will have 5 by 2 here and 7 by 2 here, right? So depending upon where I take the value of x, the expression will behave accordingly because of the presence of mod sign. So I will have to take three cases here. The first case is when x would be less than 5 by 2. Second case is when x is greater than 7 by 2. And third case is when x is in between the two, 5 by 2 and 7 by 2, right? So let's draw these three cases. Our first case will be when x is less than 5 by 2. Between 5 by 2 and 7 by 2, guys, 5 by 2 is the lesser quantity. So naturally, if x is less than 5 by 2, x is less than 7 by 2 also. Now, if x is less than 5 by 2, here the first bracket would become negative. And for any negative number, mod ka output is always negative. So for the first term, mod of x minus 5 by 2, it will simply become minus of x minus 5 by 2. And this is nothing but 5 by 2 minus x. Similarly, the second bracket is mod of 7 by 2 minus x. Since x is less than 7 by 2, 7 by 2 minus x will be positive only. So mod of 7 by 2 minus x will be as it is, 7 by 2 minus x. In the question, we are now adding these two. So the next part is the summation of these two terms. The summation of these two terms is 5 by 2 plus 7 by 2. It is 12 by 2. Minus x is minus 2x. And this should be equal to 1. 12 by 2 is basically 6. Minus 2x is 1. That gives me 2x is equal to 5, or x is equal to 5 by 2. We started with the assumption that x is less than 5 by 2, but we have got the answer as x is equal to 5 by 2. So from this, I get the answer that x is equal to 5 by 2 and not less than 5 by 2. Okay.
This was our first case, guys. Similarly, I'll take the second case now. Second case, x is greater than 7 by 2. 7 by 2 is the greater of these two terms. So if x is greater than 7 by 2, x is naturally greater than 5 by 2 also. So mod of x minus 5 by 2, x being positive, x being greater than 5 by 2, x minus 5 by 2 will be positive. So x minus 5 by 2 would remain as it is. And mod of 7 by 2 minus x. Since x is now greater than 7 by 2, 7 by 2 minus x will be negative. So mod of 7 by 2 minus x is minus of 7 by 2 minus x. And this becomes x minus 7 by 2. Okay. The next step is to add the two as per the question. We are adding these two parts. So summation of these two parts will be x plus x 2x. Minus 5 by 2 minus 7 by 2 is minus 12 by 2. And this should be equal to the left hand side, which I'm writing as the right hand side as of now. It is 1. So 2x minus 12 by 2 is 1. That gives me 2x minus 6 is equal to 1. Or I get x is equal to 6 plus 1, 7 divided by 2. X is 7 by 2. I started with the assumption that x is more than 7 by 2, but I'm getting x is equal to 7 by 2. Okay, I'll leave it like that. And I'll take the third possibility now. The third possibility is x is greater than 5 by 2. The third possibility is x is greater than 5 by 2, but less than 7 by 2. In that case, x minus 5 by 2 will be greater than 0 because 5 by 2, because x is more than 5 by 2. So mod of x minus 5 by 2 will be x minus 5 by 2 as it is. And similarly, 7 by 2 minus x will also be greater than 0 because x is less than 7 by 2. So mod of 7 by 2 minus x will be 7 by 2 minus x. Now, as per the question, when we add these two terms, mod of x minus 5 by 2 plus mod of 7 by 2 minus x, we'll be adding x minus 5 by 2 plus 7 by 2 minus x. Minus x plus x cancels. We only have 7 by 2 and minus 5 by 2. So 7 by 2 minus 5 by 2 is nothing but 2 upon 2, which is 1. Now, what does this tell me, guys? It tells me that for any value of x between 5 by 2 and 7 by 2, this entire expression is always equal to 1. And that's exactly what you want, right? So we have to include all values of x between 5 by 2 and 7 by 2 in the answer. And from cases 1 and 2, we also have x equal to 5 by 2 and x equal to 7 by 2. So my final answer will be a combination of these three results. And I will say that x will be greater than or equal to 5 by 2 and less than or equal to 7 by 2. And this is clearly my D option. All right, so that's a very lengthy, but yes, the conventional way of answering this particular question. I personally feel that we have to avoid this approach at all costs because it's too much time consuming. Let's look at a slightly better way of dealing with these questions. For that, we have to dig into the deeper meaning of mods. Okay, now guys, what does mod of x minus 5 by 2 actually mean? Mod of a minus b simply refers to the distance between a minus b. Now, mod of x minus 5 by 2 in that way will be the distance between x and 5 by 2. Similarly, what does mod of 7 by 2 minus x represent? It is the distance between 7 by 2 and x. The question says the distance between x and 5 by 2 plus the distance between 7 by 2 and x on the number line should be equal to 1. So next step is we draw our real number line and we take these 2 points, 5 by 2 and then 7 by 2. So distance between x and 5 by 2 plus the distance between 7 by 2 and x must add up to give you a 1. Now notice that between 5 by 2 and 7 by 2, the distance is exactly equal to 7 by 2 minus 5 by 2, which is 2 upon 2 or 1. So anyway, between 5 by 2 and 7 by 2, the distance is always 1. So if I take any value of x in between these two, the sum of the distances from 5 by 2 and 7 by 2 will always remain to be 1, right? So if I take this distance as a, this distance as b, a plus b is 1 only. If I take suppose x here in this particular place, if I call this distance as L and this distance as M, L plus M is also 1, right? So x has to lie between 5 by 2 and 7 by 2 for that matter. Also, x can be equal to 5 by 2 or 7 by 2 also. because if I take x as 5 by 2, its distance from 5 by 2 will be 0, but its distance from 7 by 2 will be 1. So total distance became 0 plus 1, which is 1 again. Similarly, I can take x as 7 by 2 also. If I take x as 7 by 2, the distance between 7 by 2 and x would be 0, and the distance of 7 by 2 and 5 by 2 is 1. The total distance again became 1. So yes, x has to be greater than or equal to 5 by 2 and less than or equal to 7 by 2, right? So that's again the D option. Now I think this is a slightly better way out, but still calculative and observational. So let's look at the best way of answering these questions, guys. All right, now if you ask me, the best way to solve these questions, rather most of the mod based problems, is to basically go with the options. Okay, the first option says 5 by 2 less than x less than 7 by 2. This is 2.5 and 3.5 actually. So put x as 3 and check. If I put x as 3, 3 minus 2.5, the mod is 0.5. Mod of 0.5 is 0.5 only. Plus 7 by 2 is 3.5 again, minus 3. The mod of 0.5 is again 0.5. The sum comes out to be 1. So I have to take values of x in between the two because they satisfy the given relation. That means I have to ignore option B and option C because they say x is less than equal to 5 by 2 or greater than 5 by 2, not including the range in between. And same for the C option. So B and C are ruled out. The only difference between options A and D is x can be equal to 5 by 2 and 7 by 2 in the option D. Basically, it's a closed interval. And in the A option, it's an open interval. X is more than but not equal to 5 by 2, and x is less than but not equal to 7 by 2. So to eliminate one between these two, you substitute the value of x as 2.5 or 3.5 for that matter. Anybody would suffice, any term would suffice. Putting x equal to 2.5 here, mod of 2.5 minus 2.5 is 0. Mod 0 is 0 only. Plus mod of 3.5 minus 2.5. 3.5 minus 2.5 is 1. Mod of 1 will be 1. The total distance or total sum is still 1. So yes, x is equal to 2.5 satisfies the given condition. That means that yes, x has to be equal to 5 by 2 or 2.5. So option A is also ruled out. The correct answer is option D. So that's a quicker way out. I believe there's a more universal way in which you can tackle all the mod-based questions.
Hey guys, please solve this next question from CAT 2018, the first slot. Please pause the video and try it, and you can resume for the solution. All right, guys, if f of x plus 2 is f of x plus f of x plus 1 for all positive integers x, f11 is 91, f15 is 617, then f10 equals what? So if I treat f of 1, f of 2, f of 3, f of 4, etc. up to f of n plus 1, f of n plus 2, the question says that any number, any number is the sum of the two previous terms. Naturally, it can't be f of 1 and f of 2 for that matter, right? So f of 3 is actually f of 1 plus f of 2. Or f of 4 will be actually f of 2 plus f of 3. Likewise, you can see f of n plus 2 will be f of n plus f of n plus 1. This series where every term is sum of the previous two terms is also called as the Fibonacci series. So in the Fibonacci series, every term is basically sum of its two preceding terms. Okay, now we have been given f of 11 is 91. Just write f of 11 here as 91. Let me suppose f of 12 is equal to x. By our definition, f of 13 will be x plus 91. Right? The given term will be sum of the two previous terms. Similarly, I could figure out f of 14 also. F of 14 will be sum of these two terms. X plus 91 plus x. 2x plus 91. And by the same logic, we can figure out f of 15 also. F of 15 will be sum of these two numbers, the two previous terms. 2x and x will be 3x plus 91 and 91 is 182. So f of 15 is 3x plus 182. In the question, we have been given this value as 617. So now we can solve for x. So I can write 3x is equal to 617 minus 182 will be 435. So x will be 3 ones are 3, 3 fours are 12, and 3 fives are 15. And hence we have found the value of f of 12 here as 145. And also this f of 12 will be f of 10 plus 91. So 145 will be f of 10 plus 91. From here, I can easily figure out the value of f of 10. F of 10 will be 145 minus 91. It will simply be equal to 54. So the answer to my question, f of 10 will be 54. Hey guys, you can try this next question from CAT 2018, the first lot. Please pause the video and give it a try and resume for the solution. All right, while multiplying three real numbers, Ashok took one number as 73 instead of 37. As the result, the product went up by 720. Then the minimum possible value of sum of the squares of the other two numbers is. So guys, there are three real numbers. Real numbers means they can be positive, negative, rational, irrational, any of them, right? Ashok took one of the numbers as 73 instead of 37. That means he was supposed to take 37, but he took 73. So out of these three real numbers, one number is 37. Let the other two numbers be x and y, right? So 37, x and y, these were the three numbers he was supposed to multiply, and the product would have been 37xy. But the mistake he's making is he's taking 37 as 73. So the other two numbers are x and y. The product he's calculating is 73xy. And as a result, the product went up by 720. So 73xy minus 37xy will be equal to 720. This gives me 36 into xy is 720. Dividing both sides by 36, x into y is 20. They're asking me the minimum possible value of sum of the squares of the other two numbers. Other two numbers, I have assumed them as x and y. Here afterwards, I have two ways to approach the given question. The sum of the squares of x and y will be x square plus y square. The question demands the minimum value of x square plus y square. Now guys, notice that I don't know anything about x and y. They are only mentioned as real numbers. So they can be positive, negative, rational, irrational, anything. But if I talk about x square will definitely be a positive real number, right? Because perfect squares are always non-negative. And since Raj is multiplying, and since Ashok is multiplying and getting something non-zero, x is also non-zero number. So x square is positive for sure. And same for y square. X square and y square are both positive, right? For two positive numbers, x square and y square, the arithmetic mean or AM, arithmetic mean, x square plus y square upon 2 is the arithmetic mean of x square and y square. The AM will be greater than or equal to the geometric mean, that is GM. For two numbers, geometric mean is square root of their product. The product of x square and y square, we take the square root, we get geometric mean. Now next step, I already know the value of x into y. So from here, I can get x square y square. X square y square is 20 ka square, 400. And that I'll substitute here. So I will get x square plus y square divided by 2 will be greater than equal to root of 400. Okay, root of 400 is actually 20. Multiply by 2 on both sides, you get x square plus y square is greater than equal to 2 into 20, and that is 40. That's the answer to my question. The minimum value of sum of the squares of the other two numbers is nothing but 40. So that's one way of getting the answer, guys. There is one more way out based on common sense or some observation here. Pay attention that if I give you x into y as 25, and ask you to observe the sum of x plus y. Guys, you will note that when I put x as 1 and y is 25, the sum of x and y is 1 plus 25, that is 26. Same way, if I take x as 5 and y as 5, now 5 plus 5, the value of x plus y is 10. You can take many other values to do this, to verify this, basically. But just one thing, whenever the product of two numbers is constant, their sum is minimum when they are equal to each other. Right? So product being constant, if I have to minimize the sum, I have to keep the numbers equal or as close as possible. So given that x square y square is 400, if I ask you what is the minimum value of x square plus y square, That will happen when these two numbers will both be equal, and that will be 20 each. So minimum value of x square plus y square is 20 plus 20, which is equal to 40. And that's the answer to your question, 40. Hi, don't forget to check out my course for the quant section of the CAT exam, where I've explained all concepts, tips and tricks, shortcuts, and past year questions in great detail. Hi guys, you can solve this next question from CAT 2018, the first lot. Please pause the video and give it a try, and you can resume for the solution. All right, so let's look at the first method to solve the question. We have been given P as log of 81 to the base 12. Now this we can simplify as log of 3 raised to 4 and the base is 12. The 4 will come outside. P will be 4 times log of 3 to the base 12. And now we want the value of the expression thrice of 4 minus P upon 4 plus P. Okay. So in that we can substitute the value of P directly. Thrice of 4 minus P is 4 times log 3 to the base 12 upon 4 plus P will be 4 plus 4 times log of 3 to the base 12. So 4 will get cancelled out everywhere. I will get thrice of 1 minus log 3 to the base 12 upon 1 plus log of 3 to the base 12, right? And now guys, we'll use the property that log of x to the base y is always 1 upon log of y to the base x. So using this property, wherever we have log of 3 to the base 12, we will simply replace it by 1 upon log of 12 to the base 3. The expression now becomes 3 into 1 minus 1 upon log of 12 to the base 3 divided by, below we will have 1 plus 1 upon log of 12 to the base 3. Now this we can cross multiply above and below, and we'll get thrice of log 12 to the base 3 minus 1 upon log 12 to the base 3, and below we will have log of 12 to the base 3 plus 1. Log 12 to the base 3 here also, we'll get cancelled that above and below, okay? So this is what I'm left with. This one and this one, let's write them as log of 3 to the base 3. So the numerator will be thrice of log 12 to the base 3 minus log 3 divided by, the denominator will be log of 12 to the base 3 plus log of 3 to the base 3. Now this part is log a minus log b. This will happen when we have log of a upon b. So the numerator is log of 12 upon 3 to the base 3. And in the denominator, we have log of a plus log b. That happens when the numbers a and b are multiplied. So 12 and 3 get multiplied, the base will be 3. So the expression now becomes thrice of log 4 to the base 3 divided by log of 36 to the base 3. Now we have the common base 3 here. So finally I can write this as 3 into log of 4 to the base 36 is equal to, I can write log of 4 to the base 36 and 3 here. The 3 can be taken here above. So this is log of 4 cubed to the base 36, or this is log of 64 to the base 36. 64 is 8 square and 36 is 6 square, and we have log. So 2 comes in the numerator and 2 in the denominator. 2 upon 2 into log of 8 to the base 6 is my final answer. That is log of 8 to the base 6. Very clearly, this is my B option. So that is one method of answering the question here, guys. There is a very quick method of answering the question here, which I have discussed in my course. You can check out the description if you want to understand this shortcut and all other shortcuts in great detail. Hi guys, this is your next question from CAT 2018, the first lot. You can pause the video and try it once and resume for the solution. Alright, so this is a very typical question that they have been asking in CAT since a very long time. The first time this appeared was I think 2005 or 3, and in the last CAT paper 2024, every slot had one question based on this concept. I have solved all those questions. You can find the link in the description also for the same. So let's start understanding this question. We have u square plus u minus 2v minus 1 the whole square is minus 4v into u plus v. Now before we solve further, guys, it is implicit or understood that u and v are basically real numbers. Okay, if nothing is mentioned about u and v, by default we consider them as real numbers. So now we just add 4v into u plus v on both sides. Okay, we just add 4v into u plus v on both sides. Okay, so on the right hand side, you already have minus 4v into u plus v. If you add the same thing, the right hand side becomes completely 0. Your left hand side will now become u square plus 4v into u plus v plus the remaining term is u minus 2v minus 1 the whole square. This entire term is simply 0. Now, when I open this bracket, guys, it becomes u square plus 4 into u into v plus 4v into v is 4v square plus the second term is as it is u minus 2v minus 1 the whole square is 0. Now, this entire thing is actually u square plus 2 into u into 2v plus 2v the whole square, right? This exactly resembles your a square plus 2ab plus b square, and that's the expansion of a plus b the whole square. So this entire expression is nothing but u plus 2v the whole square plus the second part is also u minus 2v minus 1 the whole square, and this is equal to 0. Now this is like saying if I call this as x and if I call this as y, we have x square plus y square is equal to 0. Since u and v are real numbers, u plus 2v that is x, u minus 2v minus 1 that is y, they are also real numbers. The squares of two real numbers is 0. This can only happen when both x and y are both equal to 0. So we can conclusively say that u plus 2v is 0 and u minus 2v minus 1 is also 0. We just add these two equations. We get u plus u is 2u. 2v minus 2v will be cancelled. Minus 1 will be as it is. 0 plus 0 is 0. 2u minus 1 is 0. I have 2u is equal to 1, adding 1 to both sides, or u is simply equal to 1 by 2. This value of u I could substitute in any of these two equations. For simplicity, I am putting it here. I will get 1 by 2 plus 2 into v is equal to 0, or 2v is equal to minus half. That gives me v is equal to minus 1 by 4. So we have figured out u as 1 by 2 and we have figured out v as minus 1 by 4. Let's plug in the values in this given expression. We want to find out u plus 3v. That will be equal to 1 by 2 plus 3 into minus 1 by 4. This is half minus 3/4. Half minus 3/4 is minus a quarter, minus 1 by 4. And this is the answer to our question, the D option. So it's a very typical question. It is also called as algebraic tautology. So as mentioned earlier, I have also solved many other similar questions from CAT 24. You can check out the link in the description for the same. Hi everyone, you can try this next question from CAT 2018, the first lot. Please pause the video and you can resume for the solution. So the question says, let x, y and z be three positive real numbers in a geometric progression such that x is less than y which is less than z. If 5x, 16y and 12z are in arithmetic progression, then the common ratio of the geometric progression is. Right, so very straightforward question. The three numbers x, y and z are three positive real numbers that form a geometric progression, right? So let us suppose that the numbers are a, ar and a r square, a being the first term and r being the common ratio of the GP. So first term is a, second term is a multiplied by r, and ar into r will give you ar square, right? These are the three terms x, y, z forming a geometric progression. Now given that 5x, 16y and 12z are in an arithmetic progression, 5x will be 5 into a, that is 5a, 16y will be 16 into ar, 16ar, and 12z will be 12 into ar square, 12ar square. If these three numbers are in AP, the middle term is the arithmetic mean of the two extremes. So I can say 16ar is the average of 5a and 12ar square. So divide this by 2. Multiply by 2 on both sides. I get 32ar is equal to 5a plus 12ar square. Let's divide by a throughout. If I divide by a throughout, a gets cancelled. It has to get cancelled because x, that is a, is also a positive real number, non-zero, so we can cancel it out easily. This gives me 32r is 5 plus 12r square. Subtract 32r from both sides. I get 12r square minus 32r plus 5 is equal to 0. Now this is a quadratic equation which can be factorized as 12r square minus 30r minus 2r plus 5 is equal to 0. Between these two I can take a 6r common. I will get 2r minus 5 remaining. Between these two I can just take minus 1 common. 2r minus 5 remaining will be equal to 0. So 2r minus 5 from this bracket, 2r minus 5 common, and what remains is 6r minus 1, it is equal to 0. So either this part is 0 or this part is 0. The first part 2r minus 5 will be 0 when r will be equal to 5 by 2. 6r minus 1 will be 0 when 6r is equal to 1 or r is equal to 1 by 6. So now we have two possible answer options. It's either A or D. But the point is, the question tells us that x is less than y, which is less than z. Here comes the significance of this statement. If x is a positive real number, that means a is also a positive real number. A into 1 by 6 will be the value of y. That means y has become less than a. If you further multiply it by 1 by 6, z will be a into 1 by 6 into 1 by 6. So z will be further lesser than y. So in this case, if the common ratio r is 1 by 6, the terms x, y, z will be in GP. But in that case, x will be the greatest term, which is a. The next term will be a by 6, that will be lesser than x. And the next term will be a by 36, which is further lesser than y. But we don't want this, we want the reverse of this, right? So the common ratio can't be 1 by 6, it is simply equal to 5 by 2. And that is our D option. Hi everyone, this is your next question from CAT 2018, the first lot. Please pause the video and try this question for some time before you jump into the solution. Alright, so given that x raised to 2018 into y raised to 2017 is 1 by 2 and x raised to 2016 into y raised to 2019 is equal to 8, the value of x square plus y cube is. Right, so we'll start by dividing these two equations first, right? We have x raised to 2018 multiplied by y raised to 2017 is equal to 1 by 2. We will divide this entire thing with x raised to 2016 into y raised to 2017 is equal to 8, right? So we are dividing these two equations, dividing the first equation by the second one. So if you notice, the first part of the left hand side is x raised to m divided by x raised to n will be x raised to m minus n. So x raised to 2018 minus 2016 will be x raised to 2. The next part is y raised to 2017 divided by y raised to 2019. Okay, so what we can do is we can write in the denominator y raised to 2019 minus 2017 by the law of indices. So denominator becomes y raised to 2 and the right hand side will be 1 upon 2 into 8 is 1 upon 16. Now I'll take square roots on both sides. I will get x upon y is equal to plus or minus 1 by 4. So this gives me two possibilities actually. When you cross multiply, you will get y is equal to plus 4x or you will get y is equal to minus 4x. We'll consider both the possibilities. Now this value of y you can substitute in any of these two equations, the first one here or the second one here. You can substitute the value of y in any of these two equations. I'm selecting the second one right now. Okay, I'm substituting y in the second equation. So y is equal to plus or minus 4x. We'll first put y is equal to 4x and then we'll put y is equal to minus 4x to see what we are going to get. So putting y is equal to 4x in the equation, we have x raised to 2016 into, in place of y I am putting 4x. So second part becomes 4x raised to 2019 will be equal to 8. 8 can be split as 2 raised to 3. Further, leave this x raised to 2016 as it is for time being into 4x raised to 2019 can be written as 4 raised to 2019 multiplied by x raised to 2019 will be equal to 2 raised to 3 only, right? Next step, break the 4 as 2 square. So this term becomes, this entire term would become 2 raised to 2 raised to 2019. Now this is our classic law of indices, a raised to m the whole raised to n, where the powers m and n will get multiplied. So first term is as it is, x raised to 2016 into the last term is x raised to 2019 into this term we have now got is 2 raised to 2 into 2019 will be 2 raised to 4038, and this should be equal to 2 raised to 3. Now for these two terms, I can use the first law of indices. A raised to m into a raised to n will be a raised to m plus n. So powers get added. 2016 plus 2019 will give me the sum 4035 is equal to, take the 2 raised to 4038 on the right hand side. The right hand side is 2 raised to 3 divided by 2 raised to 4038. Here again the powers get subtracted. So the right hand side is actually 2 raised to minus 4035 and the left hand side is x raised to 4035. Just last step, the right hand side we will write it as 2 raised to minus 1 raised to 4035, right? So now x raised to 4035 is same as 2 raised to minus 1 raised to 4035. Comparing these two, I will get x is 2 raised to minus 1. So here I get x is 2 raised to minus 1, that is 1 by 2. I have found the value of x is equal to 1 by 2 in the first case. So I've got x is equal to 1 by 2. This is when y is 4x. So I substitute the value of x as 1 by 2 in the equation. I get y is equal to 4 into 1 by 2, and that is 2. So in the first case, or as per the first case, x is 1 by 2 and y is equal to 2. Guys, similarly, if I substitute y is equal to minus 4x in this particular equation or this particular equation, I will get x is equal to minus 1 by 2, right? Because the minus sign will come forward towards the end also. And in that case, y will again be equal to 2 only, right? So when x is minus 1 by 2, I get the value of y as again 2, right? So the question is asking you what is the value of x square plus y cube finally. So finally, I need to figure out this value x square plus y cube. Okay, whichever of the two cases you consider, the first one or second one, the value of y is 2 in either case, right? So this part y cube will remain same in either case, and x being different in both the cases, x square will be same in both the cases, right? So x square will be either 1 by 2 square or minus 1 by 2 square. Either ways it will become 1 by 4, right? Minus 1 by 2 square or plus 1 by 2 square will end up with 1 by 4 only, right? So my final answer is 1 by 4 plus 8, and if you simplify this, this is 1 by 4 plus 32 by 4. Writing 8 as 32 by 4, you can now add the numerators. You get the final answer as 33 by 4, and that is plainly your D option, right? Simple question. The only thing is it might look lengthy because while I explained, I have like written down every step, but while you're actually solving, you need not write everything. So that's how we do it. The answer is a D option, 33 by 4. Hi guys, let's look at the next question from CAT 2018, the first lot. Don't forget to pause the video and try it once before you look at the solution. Right, so the question reads, if f of x is equal to minimum of 2x square comma 52 minus 5x, where x is any positive real number, then the maximum possible value of f of x is. Type in the answer question. So we'll start by drawing our Cartesian coordinate system. The question says f of x is minimum of 2x square and 52 minus 5x. Let's consider two graphs. The first one being y is equal to 2x square and the second graph being a straight line y is equal to 52 minus 5x. We notice that the two graphs intersect at some point given here, and since this point is visibly in the first quadrant, x is definitely a positive real number. Now notice f of x is the minimum of these two graphs, meaning at any value of x, whichever graph has a smaller y coordinate is the value of f of x at that point. As an example, when x is 0, we have the origin. At that point, y is equal to 2x square will be 2 into 0 square or 0, whereas y is equal to 52 minus 5 into 0 will be 52. Between 52 and 0, 0 is lesser. So f of x at x equal to 0 is defined by this point 0. You will notice that before this meeting point to the left, y is equal to 2x square is always smaller than 52 minus 5x. So for all the points to the left of the meeting point, we will refer the graph of y is equal to 2x square for f of x. Similarly, y is equal to 2x square will go above 52 minus 5x if you go beyond the meeting point. So beyond this meeting point to the right, 52 minus 5x will have a lesser value as compared to 2x square. So in this case, 52 minus 5x is the value of f of x. So now we can conclude that f of x is nothing but this particular graph. I am highlighting this in green. This is your graph of f of x, the minimum of these two, as highlighted here in this particular case. But our question wants the maximum possible value of f of x. We can very clearly see here that f of x is maximum at this peak where the two graphs intersect. So basically I am looking forward to the intersecting point of these two graphs. The first graph is y is equal to 2x square and the second graph is y is equal to 52 minus 5x. This meeting point is our point of maximum as required. Guys, this meeting point has some coordinates, let's say x comma y. These coordinates x comma y are present, or this point is present on both the graphs y is equal to 2x square and y is equal to 52 minus 5x, right? So the next step is, let us equate the y coordinates of both these graphs. So we'll equate the value of y for both the equations. Basically, we are equating 2x square with 52 minus 5x. So the first step is to equate 2x square and 52 minus 5x. On simplification, this becomes a quadratic 2x square plus 5x minus 52. I want two numbers whose product is 2 into 52 minus 104 and the sum should be 5. Some knowledge of tables will tell you the numbers are plus 13 and minus 8. So I can break 5x as 13x minus 8x, right? So the quadratic now becomes 2x square plus 13x minus 8x minus 52 is 0. This simplifies to 2x plus 13 into x minus 4 is 0, or x is minus 13 by 2 or x is equal to 4. But minus 13 by 2 is minus 6.5, a negative number. The question says x is a positive real number in this case. So we ignore minus 13 by 2 and we only want one value of x here, that is x is equal to 4. We have very simply found out the x coordinate of the point of intersection of these two graphs. Now we want to find out the y coordinate. Very simply, the x coordinate 4 will satisfy both the equations 2x square and 52 minus 5x, or the x coordinate 5 is a part of both the graphs y is equal to 2x square and y is equal to 52 minus 5x. So now our next step is to substitute x is equal to 4 in any of these two expressions. Y is equal to 2x square and y is equal to 52 minus 5x. Any of these two will get the value of y, or f of x as required is 32, the answer to our question. You can find 2 into 4 square, 2 into 16, 32, or 52 minus 5, 4, 20 as 32. So the maximum possible value of fx, that is y, is 32. Alright guys, so let's look at this next question from CAT 2018 slot 2, the second question. Please do give it a try and then we will discuss. Okay guys, so the question says, let a1, a2, a3, a4 up to a52 be positive integers such that a1 less than a2 less than a3 less than a52. So basically they are positive integers in the ascending order. Suppose their arithmetic mean is 1 less than the arithmetic mean of a2, a3, a4 up to a52. If a52 is 100, then the largest possible value of a1 is. So first of all, let's write the arithmetic mean of a2 plus a3 plus a4 up to a51 plus a52. These are 51 terms excluding a1. So arithmetic mean is summation of all these values upon 51 is equal to, let's say, x. I'm calling the arithmetic mean as x. Sum of all the terms divided by number of terms. Similarly, I can find out the value of arithmetic mean of a1 plus a2 plus a3 plus a51 plus a52, summation of all these numbers upon 52. This arithmetic mean is 1 less than the previous. So this is x minus 1. So from the first equation, guys, we can write a2 plus a3 plus a4 up to a52 is 51 times x. Okay, multiplying 51 on both sides. So we can eliminate 51 from here and write it here. And now putting this value a2 plus a3 up to a52 as 51x in the second equation, I will get a1 plus 51x upon 52 is x minus 1.
or I can take 51 on the right hand side. A1 plus 51x is 52x minus 52, or A1 is x minus 52. Now we want to maximize the value of x, and we have been given A52 as 100, right? So the maximum value of x will be obtained when the value of A2 is maximum, because A52 already has been given to us as 100, and we've assumed x as the arithmetic mean of this entire sequence, right? So basically, the maximum value of x will happen when we have the maximum value of A2 possible, and that will be basically equal to 50, right? So basically, we have 51 terms in an AP, 50, 51, 52, 53 up to 100, and that will maximize the value of x, right? Okay, so considering this entire sequence and arithmetic progression, okay, such that A2 is 50, okay, we can get the maximum value of x. So x is now the arithmetic mean of first term plus last term divided by 2. So x is equal to 50 plus 100 divided by 2, that's 75. Putting x as 75 in this equation, the max value of A1 can be calculated as 75 minus 52, giving you the answer 23. So your answer is option D. Max value of A1 is 23.
Hi, don't forget to check out my course for the quant section of the CAT exam, where I've explained all concepts, tips and tricks, shortcuts, and past year questions in great detail.
All right, guys, please try this next question from CAT 2018 slot 2. Very interesting question. Do give it a try, and then we will discuss to look at the solution. So the question tells us, let T1, T2, etc. be real numbers such that T1 plus T2 plus T3 up to Tn is 2n square plus 9n plus 13 for every positive integer n greater than or equal to 2. If Tk is 103, then k equals. All right. Now the question tells us T1 plus T2 plus T3 up to Tn is equal to 2n square plus 9n plus 13. What if I want to find out T1 plus T2 plus T3 up to Tn minus 1 only? So I will subtract n minus 1 in place of n. That gives me 2n minus 1 square plus 9 into n minus 1 plus 13. Okay. Now, T1 plus T2 plus T3, Tn minus 1 plus Tn, it is also there in this first series, right? So if I subtract the second equation from the first, T1 plus T2 plus T3 up to Tn minus 1 will get cancelled from both the two equations, right? On the left hand side, I will simply have Tn remaining. Tn will be equal to, on the right hand side, we have Tn square plus 9n plus 13 minus this part twice of n minus 1 square plus 9 into n minus 1 plus 13. This will basically give us 2n square plus 9n plus 13 minus, this is 2 into n square minus 2n plus 1 plus 9n minus 9 plus 13. Okay, again writing 2n square plus 9n plus 13 as it is, minus 2n square, 2 into 2 is 4 with a plus sign. Okay, minus 2 minus 9n plus 9 minus 13. So 2n square and 2n square will get cancelled. 9n and 9n gets cancelled. I'm left with 4n plus 13 minus 13 plus 9 minus 2. So this gives me 4n plus 7. That means the nth term in this expression is 4n plus 7. Now, this nth term has been given to us as 103. So equate this with 103. You will get 4n plus 7 is 103, or 4n is equal to 96, or n is equal to 24, because they have written tk here, right? So k is equal to 24. Same thing, right? All right, guys. So this is the next question from CAT 2018. Please give it a try. All right, guys. So the smallest integer n such that n cube minus 11n square plus 32n minus 28 is greater than 0 is. Type in the answer question. Now, what many people do here is they follow a very random process. They use hit and trial to find out the integer value of n here. So yes, of course, the process may begin with a little bit of hit and trial, but once you find out the first solution to this given equation, then it's all methodical. It's a very methodical process. Okay, guys. So first of all, to solve this question, we need to understand two concepts. Okay, the concept of synthetic division and the wavy curve method. Okay, if you're not aware of these two concepts, you can just revisit this from our course of quantitative aptitude. Okay, and the third module in which we have discussed algebra in detail. So the first step is to identify one possible solution to the given equation. Okay, you can start by assuming n is equal to 0, which you observe 0, 0, 0 minus 28 will not give you a 0 for the given equation. So n is equal to 0 won't satisfy this given equation. Forget the greater than equal to part. We want this equation to be 0, but n is equal to 0 does not satisfy. The next possible route can be n is equal to 1. So let's check. 1 minus 11 plus 32 minus 28 does not give you 0 again. So n is equal to 1 is not a possible solution. Let's check for n is equal to 2. 2 cube is 8 minus 11 into 2 square 4 plus 32 into 2 minus 28. That will be 8 minus 44 plus 64 minus 28. 8 plus 64 is 72. Minus 44 plus 28 is also minus 72. Yes, this gives you a 0. Right? And that tells me that the first possible route or the first possible solution to this given equation is n is equal to 2. So what we do is we write n is equal to 2 here, and then we use synthetic division to find out, okay, the other roots or the other factors for this given equation. So we have n cube means coefficient is 1, n square minus 11, coefficient of n is 32, and the constant term is minus 28. Right? And the root here is 2. So now we use synthetic division and try to find out, okay, the other factors for this given equation. So we take 1, then 1 into 2 is 2, minus 11 plus 2 is minus 9, minus 9 into 2 is minus 18, 32 minus 18 is 14, 14 2 sides 28, minus 28 plus 28 is 0. Okay, so from here, we can check out the other factors of this particular equation. Okay, we have 1 into n square minus 9 into n plus 14, the constant term, and the remainder is 0. So this equation can be simply written as n minus 2, the divisor here, into n square minus 9n plus 14. All right, now talking about this part, this is a quadratic which can be factorized as two numbers having sum minus 9 and product 14 will be minus 2 and minus 7. So this entire equation will become n minus 2 square into n minus 7. Now you want this entire equation to be greater than 0, or you want n minus 2 square into
n minus 7 greater than 0.
Now we use something called as the wavy curve method, where we plot the roots 2 and 7, and we observe that beyond the value 7, the equation is always positive. Okay, between 2 and 7, the equation is always negative. You can take any value and check. Otherwise, you can observe that the power of n minus 7 is an odd power. So there is sign change. At n is equal to 2, the power is even. So there is no sign change. The equation will still be negative. So at n is equal to 7, it is becoming 0. The equation is becoming 0. Okay, at the value of n, which is just more than this, the integral value, we will have n is equal to 8. And this is the least integral value of n, where the equation will just become positive, right? So the answer to this question is n is equal to 8. Okay, guys, so this question is a kind of a trickster. So just try it out. It's a good question, by the way. And please resume to look at the solution. Okay, guys, so the whole idea behind solving this question is we try to find out the general term of this particular expression. Okay, general term. Okay, and then we use summation. Okay, So see, we have 7 into 11. Okay. 11 into 15, 15 into 19, up to 95 into 99. Let's observe the first term everywhere. Okay. In all the plus terms that you have, 7 into 11 plus 11 into 15 plus 15 into 19. Just observe all the first terms, 7, 11, 15. They are forming an arithmetic progression with common difference 4, right? So writing the table of 4, 4 ones are 4, 4 twos are 8, 4 threes are 12. Observe that every term is 3 more than the corresponding multiple of 4. Okay, so first term here is 4 into 1 plus 3. Next term here is 4 into 2 plus 3. Next term is 4 into 3 plus 3. And likewise, the last term here is 4 into 23 plus 3. So there are 23 terms. Okay, and the last term here is having now 95 is the first number, 4 into 23 plus 3. So in general, the first term everywhere can be written as 4n plus 3, right? Putting n is equal to 1, you get 7. N is equal to 2, you get 8. N is equal to 3, you get 15, so on and so forth up to n is equal to 23, you get 95. Okay. Similarly, if you observe the second term is 7 more than a multiple of 4, right? Or it is 4 more than the corresponding multiple you took here, right? So if you took 7 as the first term here, this term here will be 4n plus 3 plus 4. That is 4n plus 7, right? This term will again be 4 into 2, 8 plus 7, 15. 4 into 3, 12 plus 7, 19. So the second term here is basically 4n plus 7. When you put n is equal to 1, you get 11. N is equal to 2, you get 15. Okay, you put n is equal to 23, you get 99. Right? So in general, any term in this expression can be written as 4n plus 3 multiplied by 4n plus 7. What next? We observe that all the terms here can be written as summation of 4n plus 3 into 4n plus 7 such that the n goes from 1 to 23. So when you put n is equal to 1, you get the first term 7 into 11. When you put n is equal to 2, you get the next term 11 into 15. When you put n is equal to 3, you get the next term 15 into 19. Likewise, if you put n is equal to 23, you get the last term 95 into 99. So now we put summation of 4n plus 3 into 4n plus 7 such that n goes from 1 to 23 and solve this question. So n will go from 1 to 23. Multiply these two. Okay, open the brackets. You will have 16n square plus 7 4s are 28 plus 3 4s are 12. 40n plus 7 3s are 21. So summation of 16n square plus 40n plus 21. This can be further written as summation of 16n square plus summation of 40n plus summation 21. Now, summation of 16n square, you can take 16 outside, guys. You will have summation of n square plus take 40 outside, summation n plus summation 21 will be 21 outside, summation of 1, right? And now we have the formula for all these expressions, right? Summation of n square is n plus 1, 2n plus 1 divided by 6, plus next term is 40 into summation of n, 40n, n plus 1 divided by 2, plus 21 times summation of 1 is nothing but n only. And in this now I put n is equal to 23. So in this equation, if I put n is equal to 23, I will get 16 into 23 into 24 into 2 23s are 46 plus 1 47 divided by 6 plus 40 into 23 into 24 divided by 2 plus 21 times 23. All right, so after this, you can simplify 6 ones are 6 fours are 2 20s are, and you can use the on-screen calculator for multiplication. The first term will be 16 times 23 times 4 times 47. That will be 69184. The first term here will be 69184. I'll write it here. 69184. Okay, the next term is 20 into 23 into 24. 20 into 23 into 24 is 11040. And the last term will be 21 into 23. That's 483. So adding them, you get 7, 8 to 16 and 420, 7, 0 and 8. 80,707. That's the answer to the question, option A.
Hi, don't forget to check out my course for the Quant section of the CAT exam, where I've explained all concepts, tips and tricks, shortcuts, and past year questions in great detail.
All right, guys. So please try out this next question and then you can resume for the solution. Okay, if a and b are integers such that 2x square minus ax plus 2 is more than 0 and x square minus bx plus 8 is more than or equal to 0 for all real numbers x, then the largest possible value of 2a minus 6b is. So it's a type in the answer question. Let's see. The first condition is 2x square minus ax plus 2 is always positive. Now the left hand side is a quadratic equation, guys. A quadratic equation is always positive when its roots are imaginary, right? It can be always positive or always negative. In both the cases, we can say that the roots are imaginary. The graph does not touch the x-axis. That means the b square minus 4ac for this equation should be basically negative or less than 0. So b here is minus a, b square minus 4 into a here is 2 and c here is also 2. B square minus 4ac is less than 0. So a square minus 16 is less than 0. This will basically give me a plus 4 into a minus 4 is less than 0. So now we know that for any quadratic equation, okay, when the coefficient of x square is positive, okay, or the coefficient of a square is positive, okay, the equation is less than 0 between the roots. That means a will be greater than minus 4 and less than plus 4. Similarly, for the second equation, we can observe that x square minus bx plus 8 is greater than or equal to 0. So here again, b square minus 4ac will be less than or equal to 0 because we have some roots possible, right? Equal to 0 also is possible. So here b square minus 4ac is again less than or equal to 0. So b square will be less than or equal to 32. Same logic like the previous one. B square minus 32 less than or equal to 0. Okay, so this will be b square minus 4 root 2 square less than or equal to 0. Same logic now. 4 root 2 with a negative sign plus 4 root 2 with a plus sign and b will lie. Okay, in between them, or less than or equal to 0 means b can be also equal to these two values. But since b is an integer, b will have to lie or b will have to take some integer value in between them, right? Now, you want the largest possible value of 2a minus 6b. So first of all, take the largest value possible for a. The largest possible value of a here is 3, since a has to be less than 4, right? And if 2a minus 6b has to be largest, we take the least possible value of b. The least possible value of b is just greater than minus 4 root 2. So an integer just greater than minus 4 root 2, for minus 4 into 1.4 is basically minus 5.6 approx. So an integer just greater than minus 5.6 will give you b is equal to minus 5. So putting a is equal to 3 and b is equal to minus 5 in this equation, the answer you need is 2 into 3 minus 6 into minus 5. 6 minus minus will become plus. 6 plus 30, your answer is 36.
Let's go on to the next question, guys. The next question says, if the sum of the squares of two numbers is 97, then which of the following cannot be their product? So let the two numbers be a and b. Okay, that sum of the squares have been given to us. A square plus b square is given to us as 97. Okay, you want to find out which of the following cannot be the value of a into b. Okay, now understand, a into b is as good as square root of a square into b square. Okay, this I realized because I have been given the sum of the squares a square and b square. So now it's very easy to relate them, right? Okay, sum has been given 97, product se deal karna hai. So basically we use am greater than equal to gm, right? So the arithmetic mean of these two numbers a square and b square is what? A square plus b square divided by 2 greater than equal to square root of a square into b square, right? So a square plus b square, if we substitute as 97, divide by 2 will be 2 4s are 8, 2 8 are 16, 48.5. Okay, So basically square root of a square b square, which is equal to ab, should be less than equal to 48.5. कौन सा ऑप्शन इससे बड़ा है? 64, and that's the required answer.
All right, guys. So please try out this next question and then you can resume for the solution. Okay, if a and b are integers such that 2x square minus ax plus 2 is more than 0 and x square minus bx plus 8 is more than or equal to 0 for all real numbers x, then the largest possible value of 2a minus 6b is. So it's a type in the answer question. Let's see. The first condition is 2x square minus ax plus 2 is always positive. Now the left hand side is a quadratic equation, guys. A quadratic equation is always positive when its roots are imaginary, right? It can be always positive or always negative. In both the cases, we can say that the roots are imaginary. The graph does not touch the x-axis. That means the b square minus 4ac for this equation should be basically negative or less than 0. So b here is minus a, b square minus 4 into a here is 2 and c here is also 2. B square minus 4ac is less than 0. So a square minus 16 is less than 0. This will basically give me a plus 4 into a minus 4 is less than 0. So now we know that for any quadratic equation, okay, when the coefficient of x square is positive, okay, or the coefficient of a square is positive, okay, the equation is less than 0 between the roots. That means a will be greater than minus 4 and less than plus 4. Similarly, for the second equation, we can observe that x square minus bx plus 8 is greater than or equal to 0. So here again, b square minus 4ac will be less than or equal to 0 because we have some roots possible, right? Equal to 0 also is possible. So here b square minus 4ac is again less than or equal to 0. So b square will be less than or equal to 32. Same logic like the previous one. B square minus 32 less than or equal to 0. Okay, so this will be b square minus 4 root 2 square less than or equal to 0. Same logic now. 4 root 2 with a negative sign plus 4 root 2 with a plus sign and b will lie. Okay, in between them, or less than or equal to 0 means b can be also equal to these two values. But since b is an integer, b will have to lie or b will have to take some integer value in between them, right? Now, you want the largest possible value of 2a minus 6b. So first of all, take the largest value possible for a. The largest possible value of a here is 3, since a has to be less than 4, right? And if 2a minus 6b has to be largest, we take the least possible value of b. The least possible value of b is just greater than minus 4 root 2. So an integer just greater than minus 4 root 2, 4 minus 4 into 1.4 is basically minus 5.6 approx. So an integer just greater than minus 5.6 will give you b is equal to minus 5. So putting a is equal to 3 and b is equal to minus 5 in this equation, the answer you need is 2 into 3 minus 6 into minus 5. 6 minus minus will become plus. 6 plus 30, your answer is 36. Okay, so the question says arithmetic mean of x, y, and z is 80 and x, y, z, u, and v is 75. Okay, if u is x plus y upon 2 and v is y plus z upon 2 and x is greater than or equal to z, then the minimum possible value of x is. Okay, so from this statement, the arithmetic mean of x, y, and z is 80. So x plus y plus z upon 3 should be 80, or x plus y plus z is 3 into 80, that's 240, right? Same way, x, y, z, u, and v, the arithmetic mean is 75. So I can say x plus y plus z plus u plus v divide by 5 is the arithmetic mean 75. So x plus y plus z plus u plus v is equal to 75 into 5. That's 375. All right. Now this value I need to put in the second equation. I'll get 240 plus u plus v will be 375, giving me u plus v is 375 minus 240. That's 135. All right. Now what I'm going to do, I'm going to add these two equations, right? And I will get u plus v is equal to, you can take half common from both of them, half into x plus y plus z can be written as z plus y, isn't it? Okay, I've simply added these two equations, right? So u plus v, I know it's 135, and x plus y plus z, again, I know it is 240. Just plug in these two values. Here I put 240 and here I put 135. So I'm going to get 135 is equal to half of 240 plus y. Take 2 on the left hand side. You will have 270 is y plus 240, or you will get y is equal to 30. Now, if y is equal to 30, I put in this equation. I will get x plus z is 240 minus 30, 210. Now, I want the minimum possible value of x, and x is greater than or equal to z. That means both can be 105 each. Okay, I cannot take any value of x, okay, less than this, right? Because x is greater than or equal to z, right? So the answer here is minimum possible value of x is 105. So this question is a typical example of how many a times, if you're good in mathematical jugglery, if you're good in handling equations, okay, just plugging in the values many a times, you can get the answer.
Hi, don't forget to check out my course for the Quant section of the CAT exam, where I've explained all concepts, tips and tricks, shortcuts, and past year questions in great detail.
Okay, guys, so please solve this one. All right, guys. So f of x is max of 5x or 52 minus 2x square. Okay, so let's start by drawing y is equal to 5x. Y is equal to 5x will be a straight line passing through the origin like this. Okay, guys. And next, you want to plot 52 minus 2x square. So for this, we can use the method of transpose, guys. We can look at y is equal to, let's say, x square. Then y is equal to minus 2x square. Okay, and then plus 52. That's what we need, right? So y is equal to x square will be something like this. Okay, 2x square will be steeper and minus 2x square will be inverted, right? Something like this. Okay, and if you're basically taking it up by 52 units, okay. Now the question says f of x is maximum of these two. Okay, maximum means we take the larger value. Okay, so if you observe carefully, guys, at one point, both of these graphs will meet. Okay, and to the left side of that particular point, this graph will dominate. Okay, up till you get here, of course. Then again, this graph will dominate. And again, to the right of this meeting point, only this graph will dominate, right? So my answer has to be, or like my target graph would basically look like this. Okay, it is the maximum. Okay, it is the maximum of these two. Okay, and x is a positive real number. Perfect. So I don't need to bother about this negative region at all. Okay, now in this, they're asking you what is the minimum possible value of fx. The minimum possible value, as you can observe, guys, it occurs at the point where both the graphs meet. Okay, so I have to equate these two values, and that's how I get the minimum possible value of fx. Okay, the value at which the two graphs basically meet. So 5x will be equal to 52 minus 2x square. Okay, so you will get 2x square plus 5x minus 52 is 0. It's a quadratic equation. It can be solved. 2x square plus 13x minus 8x minus 52 is 0. So basically you can take x common, 2x plus 13 minus 4 common, 2x plus 13 will be equal to 0, or x minus 4 into 2x plus 13 is equal to 0, will give me x as either 4 or minus 13 upon 2 or 6.5. minus 6.5 or 4. But since x is a positive real number, forget about this. Okay, of course, they're talking about this meeting point, okay, which will lie here, somewhere over here, right? Okay, but we are not interested in that. We simply want to find out the minimum value of this particular function. And we have realized that minimum value will occur when x is equal to 4. So put x is equal to 4 in either 5x or 52 minus 2x square. You get the minimum value of f of x that happens at f of 4. So that will be 5 into 4, which is 20. So minimum value of f of x, your answer is 20.